بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is the second major of term 221 of calculus 2. Let us enjoy watching and solving it together. The first question: find the exact length of the curve, this function. So we know the formula. The length of the curve is called L, and it is integral either with respect to x or with respect to y. Since he said here that x is between 0 and 1, so I will use the formula where I have dx here with respect to x. So x runs from 0 to 1, and the formula is square root of 1 plus the derivative dy by dx to the power 2. Well, if y is given, then I will have here dy, the integral would be with respect to y dy, and here I will have dx by dy. So I need the equation to be written in terms of x, and I'll find x prime or dx by dy. But here I have x from 0 to 1, so I'll use this formula. So I need dy by dx, which is y prime. So let me find y prime. Well, derivative of 1 is 0, 6 is a constant, derivative of x to the power 3 over 2 is 3 over 2 times 6. So when I multiply 3 over 2 times 6, I get 9. X to the power 3 over 2 minus 1, and that's half. So actually, y prime is 9 square root of x. I need y prime square. So y prime square would be squaring this, raise this to the power 2. So I'll have 81, and square root of x, when you raise it to the power 2, you get x. So the formula would be integral from 0 to 1, square root of 1 plus 81 x dx. And now you find this integral. Well, we have inside the square root a linear function. So the integral, when we have linear function, the integral would be, this would be 1 plus 81x to the power half. So the integral would be 1 plus 81x to the power half. You add 1, so you get 3 over 2. And then you divide by 3 over 2, or you multiply by 2 over 3. And then you should divide by the derivative of the linear function. So derivative of 1 is 0, derivative of 81x is 81. So that's the integral of square root of 1 plus 81x from 0 to 1. So I replace x by 1 first, and then I replace x by 0. But let me simplify this, take 81 outside. So I'll have 2 over 3 times 81, that's 243, okay? And then times 1 plus 81x to the power 3 over 2 from 0 to 1. This means that I replace x first by 1. So I'll have 1 plus 81 times 1, that's 82. So I'll have 82 to the power 3 over 2. Minus, I replace x by 0, so I'll get 1. 1 to the power 3 over 2 is just 1. And this would be the final answer. This is the exact answer. You can approximate using the calculator, but there is no need. That's the exact answer. but you can check your answer by calculator if you like. So find an approximation of this and put this in the calculator and make sure that your answer is correct. Determine whether the following integral is convergent or divergent. So when he says like this means that we having an improper integral. And you know we have two kinds of improper integrals. Either we have infinity or negative infinity or both. This is the first type of improper integral. The second type, if the function is not continuous in the interval. Okay, but here we have infinity, so we know the definition. The definition is limit. We replace infinity by t, and we take t to infinity. Okay, so from 2 to infinity, integral from 2 to t, limit t goes to infinity, integral 2 to t x over square root of x squared minus 1 dx. That's the first step. Now I need to find this integral. Okay, what is this integral? Let us say the indefinite integral. Okay, so let me write it carefully. Okay, let me try to find here the integral of x over square root of x squared minus 1. Well, the derivative of x squared minus 1 is 2x. So I need 2 here, and I will multiply by half outside. So I will have half, if I take now u equals x squared minus 1, solve it by substitution. So du would be 2x dx. So 2x dx would be du, and I'll have square root of x squared minus 1, which is u. And this one I can write it as square root of u as u to the power half, but when I take it up, it would be u to the power negative half du. And the integral of u to the power negative half is u to the power negative half plus 1. So it's u to the power half over half, or just multiplied by 2. So 2 cancels with 2, and I'll have u to the power half or square root of u, which is a square root of x squared minus 1. So in fact, the integral of x over square root of x squared minus 1 is just square root of x squared minus 1. So this would be equal to limit t approaches infinity of square root of x squared minus 1. That's the integral from 2 to t. So first I replace x by t, so I'll have square root of t squared minus 1, okay, and minus square root. Now I replace x by 2, 4 minus 1 is 3, so I'll have this. Now I find the limits. When I replace t by infinity, I'll have infinity squared, which is infinity, minus 1, which is infinity. Square root of infinity is also infinity. Infinity minus square root of 3 is also infinity. So the integral will go to infinity, and this means that the integral is divergent. So if I call this integral I can say here I is divergent. Okay, the integral is divergent. Evaluate this integral. Well, I have tan x plus 1 raised to the power 2. So I cannot do anything with tan x plus 1. So why don't we expand? Let's see what happens when we expand. So you have tan x, we raise it to the power 2. So we have tan square x, then plus 2 times 1 times tan. So 2 times tan x plus 1 to the power 2, which is 1. Now we have 3 terms. Well, how to find the derivative, the integral of tan square? Okay, what is the integral of tan square. I don't have a quick formula for that. But I have tan square x plus 1. Okay, and I know that tan square x plus 1 is equal to secant square x. And I know the integral of secant square. It is tan because the derivative of tan is secant square. So why don't we write this integral as tan square plus 1? I write it as secant square x, then plus 2 tan x. And now I have 2 terms instead of 3, and I can find the integral of secant square. So the integral of secant square is in fact tan x, because the derivative of tan is secant square. And you should memorize a formula to find the integral of tan x. It is ln absolute value of secant x plus c. If you forget this formula, you can write tan x as sine x over cosine x, and take u equals to cosine x. Then the derivative of cosine is sine. So I'll have du over u, which is ln u, or ln derivative of cosine is negative sign. So there will be a negative sign here. So it will be negative ln cosine, or if you take this minus up, so ln cosine to the power negative 1, which is secant. So ln secant x. So this is how to show that integral of tan is ln secant, but you can immediately use it. You can just write integral of tan ln secant, and that's accepted. Evaluate this integral. Well, what do we have here? We have a rational function, and the derivative of the denominator is 2x minus 5. We don't have 2x minus 5 up, and we can manipulate here to have 2x minus 5, but it will not solve the integral. We will have two integrals, and again we have to deal with this function, x squared minus 5x plus 6, this polynomial. So I will use section 7.4, partial fractions. So I will write x minus 4 over x squared minus 5x plus 6. First, I will factor the denominator. Two numbers, their product is 6, their sum is negative 5. So negative 6 and 1. Okay, negative 6. Okay, that's it. And now I write it as, I have two linear factors, so I can write it as a over x minus 6 plus b over x plus 1. And now to determine a and b, we have a quick way to do that if we replace x by 6 here. Okay, so I cancel this, I forget about this, and I replace x by 6. So 6 minus 4 would be 2, and 6 plus 1 would be 7. Well, there is a problem here. There is a problem. This factoring is not correct, because negative 7 times 1 is not positive. So negative 6 times 1 is not 6. So in fact, I think negative 2 and negative 3. Okay. So now the product, negative 2 times negative 3 is 6, and okay, that's correct. So let me correct my mistake. So x minus 2 and x minus 3. So now to find a and b, let me cancel this and replace x by 2. So 2 minus 4 is negative 2. 2 minus 3 is negative 1. So a is 2. And now I cancel the other one, and I replace x by 3. So 3 minus 4, that's negative 1. 3 minus 2, that's 1. So b is negative 1. So this is how to find A and B quickly. So this integral would be, if I call it I would be equal to integral from 0 to 1. A is 2, so I'll have 2 over x minus 2. B is -1, so I write it -1 over x minus 3 dx. And now this integral is easy. 2 is a constant, take it outside. Integral of 1 over x minus 2 is the ln absolute value of x minus 2 minus ln integral absolute value of x minus 3 from 0 to 1. So let me replace x first by 1. So I'll have 2 ln 1 minus 2 is -1. Absolute value of -1 is 1. So I'll have ln 1. And this is 0, in fact. Ln 1 is 0. So minus ln x is 1, 1 minus 3, -2, absolute value 2, so ln 2. So that's the first one. Then let me replace x by 0, 0. So ln 2, I'll have 2 ln 2 minus, replace x by 0, so I'll have ln 3. So I'm having negative ln 2, -2 ln 2, and negative times negative would be positive ln 3. So the exact answer would be -3 ln 2 plus ln 3. Negative ln 2, -2 ln 2, you add -1 and -2, and that's the exact answer. We need the exact answer. You don't have to approximate by the calculator. But again, to check the answer, approximate and find this using the calculator and check that your answer is correct. How to find the integral of ln x over x squared, and there is a missing dx here. How to find this integral? Well, ln, I do not know the integral of ln. So we usually, when we have a polynomial or times ln x, we use integration by parts. And we usually take u as ln x because we know its derivative. The derivative is 1 over x dx. We don't know the integral of ln x. We need to use integration by parts to find the integral of ln x. And the other function is x squared. I'll take it as dv. So this is x to the power -2, not x squared. And this function I need to integrate. So v would be the integral of x to the power -2. It would be x to the power -1 when we add 1 over -1. So you can say it is -1 over x. So now this integral would be equal to u times v. You multiply these two, u times v. So I'll have negative ln x over x, then minus integral v du. You multiply these two. So -1 over x times 1 over x would be -1 over x squared, or I can write it x to the power -2. So the final answer would be negative ln x over x, and minus times minus is plus. So I need the integral of x to the power -2, which I just found here. So in fact, the integral is -1 over x, and don't forget to put plus c. That's the answer. Well, I have tan x times secant square x times over cosine. Well, 1 over cosine is secant. So if I write this as tan x secant square, and this is 1 over cosine, so if you bring it up, it would be another secant. So secant square times secant, so I'll have secant cube x. So in fact, this is tan x times secant cube. And whenever we know this in section 7.3, I believe, or 2, I think 7.2. If you have tan and secant, if the power of tan is odd, take u as secant x. So du would be derivative of secant is secant tan. So this integral would be integral of, well, I have tan x, I need it. So I will write it as what? Secant square x. Secant cube, I write it secant square times secant x tan x dx. So this would be du, and secant square would be u square. So this would be the integral of secant square is u square, and secant tan dx is du. The integral is u3 over 3, and u is just secant. So final answer, secant cube x over 3 plus c, that's the answer. Evaluate the following integral, another integral, but we have this form, this root 9 minus x squared, and the derivative of 9 minus x squared is negative 2x. It's not in the numerator, we have x squared. So I can use 7.3 here. I can take x as, I have 9 minus x squared, so 3 sine theta. Okay, this is the 3 roots in 7.3. X equals 3 sine theta. I change everything from x to theta. And then dx would be derivative of 3 sine theta is 3 cosine theta d theta. And in this case, the square root, let me call this again I, okay? The square root of 9 minus x squared would be the square root of 9 minus 9 sine square theta, because when you square x, okay, you can take 9 as a common factor, and you will get 1 minus sine square theta. And then you know that 1 minus sine square theta is just cosine square theta. And here there is a domain for theta in which the root would be the positive cosine theta. Square root of cosine square is cosine, absolute value of cosine theta, but because of the domain we chose for theta, it would be 3 cosine theta. So I can write integral I now as x squared is what? Is 9 sine square theta. The root appears to be 3 cosine theta. dx is 3 cosine theta d theta. Well, I can cancel 3 cosine theta with 3 cosine theta, and I'll have 9 sine square theta, and I can just take 9 outside because it's a constant. How to deal with sine square? We know in section 7.2, we write it using this formula. We change it to 1 minus cosine 2 theta over 2. Okay, this is a formula. And I can take the 2 outside, so I'll have 9 over 2, and I need to find the integral of this function. The integral is easy. Integral of 1 is theta. Integral of cosine is sine, because the derivative of sine is cosine, but I have 2 theta, so I divide by 2. That's it, plus c. But now we have to go back to x, from theta to x. So what is the relation between x and theta? That's the relation between x and theta. So from here, I have sine theta equals x over 3, if you divide by 3. So I can find the triangle of theta. Sine is the opposite over hypotenuse, don't forget. So, yeah, 2. Okay. So ka 2, sine opposite over hypotenuse. To find the adjacent, well, it is the largest side here is the hypotenuse. So I square 3, which is 9, and minus x square using Pythagorean theorem. So now to change back to x, how to change theta to x? Well, sine theta is x over 3, so theta would be sine inverse x over 3. And I have half here, and I have sine 2 theta. Well, sine 2 theta, there is a formula that it is equal to 2 sine theta cosine theta. So I have 2, okay, times sine theta, which is x over 3, times cosine theta k, which is adjacent over hypotenuse. So it's square root of 9 minus x squared over 3 plus c. So the final answer is this one. You can just cancel the 2 with 2, and that would be the final answer. The last part is this integral. Well, not much information here. 1 minus cosine in the denominator. I really don't have any formula or any method to deal with this integral. So we studied in 7.5 that maybe multiplying by the conjugate will solve the problem. So let us try. I'll have in the numerator 1 plus cosine x, and in the denominator 1 minus cosine times 1 plus cosine would be 1 minus cosine square x. X minus y times x plus y, x square minus y square. But 1 minus cosine square is just sine square, because sine square plus cosine square is 1. And now I have 1 plus cosine. So I can write it 1 over sine square, distribute 1 over sine square. And 1 over sine square is cosecant square. And I know the integral of cosecant square, negative cotan, because the derivative of cotan is negative cosecant square. And the other one is plus, let me write it here, plus cosine over sine square. Cosine over sine square. I can solve this by substitution. I can take sine x as u, because the derivative is cosine, and it would be integral of 1 over u square. You can do that, it's okay. Or I can also write this as cosine x over sine x times 1 over sine x. And cosine over sine is cotan, and 1 over sine is cosecant. So in fact, I have cotan x times cosecant x, and there is a formula for cotan cosecant. The integral is negative cosecant, because the derivative of cosecant is negative cosecant cotan. So the final answer would be integral of cosecant square is negative cotan x, and integral of cotan cosecant is negative cosecant x plus c. This would be the final answer. I hope you enjoyed solving this exam with me.